here. It's definitely hard to find this place as well. So we may have some people come in. It didn't help probably that we were webcasting this as well on a rainy day where the tea's not working. But I'm glad you guys came. Thank you for coming. If you tweet, here's our hashtag. I hope some of you do. I wanted to start off before Dietrich starts, and I'll introduce him formally. I wanted to talk, just sort of relate, I think, why I think data science is good for us to start learning. And I thought about what's a good example to connect the physical library to the virtual where we're going, right? And oftentimes when people, actually one thing I should say is we're in the old library right now. This used to be the old library. Now it's an auditorium up here at the observatory. Now we're in the other side of the building. But whenever people come and visit me, one of the first things I do when I introduce them, they come into my office, is I show them this card. If many of you know what it is, you know, the due date slip, and I point to a name on there, and you know, people smile, and because it's Carl Sagan. You can't see it, maybe, and people on the camera, but Carl Sagan actually did his research here in the '60s, the origins of life, and so like you know, when people smile, they start making these connections. Like, you know, that's a guy I used to listen or watch on Cosmos. If many of you know Carl Sagan, or he also did the movie Contact. Depends on how you see that movie. I liked it. Some people hate it. But all these connections, actually, all these links, it's actually stuff that we do all the time. You know, like when we're cataloging, or we're doing, you know, like we're doing reference even. We create lists of links to helpful resources and things of that sort. So librarians are kind of gathering data points all the time, linking things and sort of creating data all the time. And so I think there's a definite need. I mean, a need for us, and we're not linking up to this community, this data science movement. And there's a definite need. Every time I hear a data scientist speak, they say, I spend most of my time doing what we do, actually. And you know, the trouble is that we're not relating what we do well, I think, to the outside world, and how much of a resource we are, and that we're also not retooling at this time. We're not upgrading our skills. But so the other thing is that people say, like, am I going to learn everything about data science? Well, no, you know, you're going to learn about it. You're going to learn about it. There's particular aspects that are difficult. Statistical side of things, the statistical analysis is very difficult, but you'll gain a better understanding of you know, of how researchers work, and then also be able to upgrade your own skills at the same time. So I'll get on to David. We're very lucky to have him here. He usually speaks for big data projects, and he likes the fact that librarians are getting into this as well. And I just wanted to read a little bit about David. David is an advisory technical education consultant in EMC's Global Education Services Organization, where he leads the curriculum, strategy, and course development related to big data, analytics, and data science. He co-authored the first course in EMC's data science curriculum, and more recently was a contributing author for 2 new EMC courses focused on teaching leaders and executives about big data and data science. I'm not going to read the rest, because you can see that David's done a lot. and so we're lucky that he's here to talk about the data science life cycle. So without further ado, I'll introduce David here and switch to his slides.
Thank you. Sound okay for this? All right, good. So, see if we can just start this. Okay. So, Chris, thank you for the introduction. You know, throughout my career, I've mostly had roles or of different kinds, either leading or doing it hands-on, either strategy or analytical work of some kind. But the last 2 to 3 years, I've really lived, eaten, and breathed data science and big data. So as I've started to create curriculums in this space and courses in this space and write patents and invent IP in this space, I mean, I've been very, very heavily close to it in terms of research and projects that we've been doing. So it's about 10:15. What I'm going to do is show you some slides. We'll talk a little bit about life cycle, but part of it's also just a level set around things related to data science, how people can keep learning on these topics on their own. And then I want to make sure we have a good amount of time for Q&A with all of you. Because at least my personal experience is that tends to be some of the more interesting pieces. Maybe that's just my bias and not wanting to listen to myself speak all day either. Okay. So, I'm going to start with a quote by Anthony Goldblum, who's the CEO of Kaggle. Kaggle is like basically a crowdsourcing platform for data science projects. Are people familiar with Kaggle? No, yes, no. Okay, mostly no's. So Kaggle, basically, their motto is they make data science a sport. So what they do is they team up with predominantly large organizations, whether those are companies, governments, I think sometimes universities, and what they'll do is they'll say we have this kind of analytical problem. Here's a data set, we'll post it, and we'll put a prize next to it for anybody who wants to help us try to solve it. And the person who submits the best solution to the problem gets the prize. And the prize can be anything from zero, to free, so you can just try to get practice. And I've seen this where they posted data sets around survivors on the Titanic, predict which ones had the highest likelihood to survive given all these different attributes, right? That was zero, just to teach yourself how to do random forests. Up to $3 million to try to predict patient healthcare records and who is likely to be admitted or readmitted within 6 months after going into a hospital. So they do all kinds of contests. I can easily waste an afternoon just looking at the contests that they offer because they're pretty interesting. Anyway, Anthony Goldblum is the CEO and founder of Kaggle. And so what he does is he will go to companies and try to ask them what kind of data problems they have, right? And then, so he'll say, if I go to a company and ask, what kind of data problems can we solve, we typically get blank looks, right? But if instead he says, what kinds of things can help a company lose money and make money, he gets a lot of answers. And of those answers, usually 2 out of 3 are things that can be solved with data and solved with analytics. And I think this, to me, is a good quote that really reflects some of the things that you were saying a minute ago, Chris. I think a lot of the battle here is figuring out how do you reframe questions in a way that you can approach it with data and approach it with analytics and also drive value that's really of interest to other people. So this is really what I'm going to talk about today. There's a tag cloud around it, but I guess more traditionally we'll talk a little bit about basics, just a level set around big data. We'll talk a little bit about emerging needs for advanced analytics, sort of why this tends to be happening a lot right now, why there's a lot of emphasis right now. And I think probably where I'm going to spend a little more time is what are some of the tools and technologies that are out there and emerging in this space. And I think probably more importantly is, how do you keep developing your skills? What are ways that you can get better at this, that you can learn from other people, and that you can contribute to some of the things that are being done right now. So one of the projects that I like is this one that was done in collaboration with AT&T and researchers at MIT. It was a project they called the New York Talk Exchange. And I think one of the great things about this space is finding really creative ways to visualize data. So what they did is, instead of having a huge, painfully to look at table of numbers, they said, give me all the call records, anonymize them, and what I'm going to do is look at, what are the calling patterns, analyze what that network is of people, where they're calling in the world, how much traffic is happening, and then they overlaid it on city blocks in New York. So what we're actually looking at here is, you can see the color coding in the upper left of the world, and then on the right, you see stacked bar charts within each one of these blocks, and telling you how much density of each of these calling patterns are going from that block to other parts of the world at a given point in time. So this tells them at a pretty granular level, things about the demographics of these areas, things about, what are the patterns? Should they offer certain kinds of calling plans to people with different demographics or different calling patterns or different calling habits, right? And the other thing they did is they looked at, what time of day are these people calling these areas? So they said, what do these hotspots look like? What is the pulse of the planet, so to speak? So if I look at New York, I know that it's hitting these other hotspots, and it's hitting these other hotspots at certain times of the day in a 24-hour period. So for AT&T, this is obviously much more insightful, right? Aside from being more interesting to look at, this tells them where should they create new call centers? Where should they have new support centers? Where do they need to add more cell phone towers to support this kind of discussion and these kinds of calls? So I like this example because they took something that, was a pretty traditional kind of data set, and they actually did pretty rich analysis with it. And then they could do all kinds of other things like look at social networks of people in these calling patterns. But, at least for now, this is I think, a much richer treatment of this data. The other example that I was going to show is a project we did at EMC, which was really to try to analyze innovation within the company. So one thing we do at EMC is we have annual innovation contests. And when we do that, you have each business unit sponsors a challenge. So they'll say, we have this really hairy problem. We don't know if there's anything we can do with it, or we're just sort of hitting a brick wall, or we have the same people kind of throwing the same ideas at it. So one way to conquer that is you diversify the pool of people submitting ideas, right? So they might say, we'll offer $1,000 or $2,000 to the best idea to help us solve this very, very difficult problem. So thousands of people submit. Last year, there was maybe 2,000 ideas submitted. This year, it's actually going on right now, and there's over 4,000 ideas that have been submitted, which is a lot. So what we did is actually we looked at it in terms of social graphs. So what happens is you have multiple names on the same idea that gets submitted sometimes. And then you also have the same name submitting ideas for multiple different business unit level sponsored challenges. So what we wound up finding is that you had certain people who operated like hubs in this network. They might have submitted to an IT idea challenge, an HR challenge, an engineering challenge, right? So they would work with different people across EMC, which is almost a 60,000 person global company. So what we found is we had people, say, in Shanghai who were partnering with people in Cork, Ireland, in St. Petersburg, Russia, in parts of the United States. And these people were the common threads. These people that we pulled out wound up having overlapping connections to drive innovation with seemingly disparate people across the globe. So these were people who were quietly driving innovation. The other thing we found was there were certain very dense clusters where there was a disproportionate number of finalists in this contest from certain areas. And one of the areas we found was Cork, Ireland. And in Cork, what we learned is they'd actually undergone very specific training in innovation. And from the most executive levels of that center of excellence down to individual contributor levels, they had done different kinds of training. So at the leadership level, they said give people time to experiment on projects, build some of that into their roles. And at the other end, they said figure out how you form teams in ways that you have diverse ideas and diverse people on these teams to try to do it. So they're actually overtly encouraged to do that. And we saw a disproportionate number of them show up in this kind of analysis. So I'm showing you these examples because you probably know the potential problems you can conquer in the library space better than I do. But I think these are interesting examples. And one interesting thing about network analysis is it's not always limited to people as hubs and nodes, right? This can be ideas. These can be books. These can be articles. These can be patent submissions, right? These can be comments about literature. It can be lots of things to find out the most influential drivers in these kind of interconnected ecosystems. Okay, so I just want to talk a little bit about big data. So with big data, a lot of people talk about this as kind of 3 V's: variety, velocity, volume. So I guess I'm saying this slightly differently. Certainly there's large volumes of information. My personal take is people tend to get very fixated on the volume of the data. We have a terabyte of data, we have a petabyte of data. My personal feeling is that's kind of the less interesting part in many ways. I think probably the more salient point is there's many new sources of data. The variety is huge. In fact, I would say philosophically, that's the biggest difference. What is actually considered data today versus what was data 20 years ago or 30 years ago, right? Most people think of data, as rows and spreadsheets in an Excel file traditionally. But this is all kinds of things, right? This is social media, this is video, this is genetic sequencing, this is sensors and chips, it's MRI and medical imagery, right? It's things like clickstream data. So it's lots and lots of things that you can use to mash up together and try to analyze and get something more insightful out of it. Really, of all these things, the biggest drivers are heavily surveillance video, right? So video footage is a huge, huge driver. That has taken up a huge amount of space and driving this growth in volume. And the other are RFID chips and sensor chips, right? These are things that are in your cell phone. These are things in your GPS. And these are things in many, many, many other devices that are recording and sending and sharing information about your geospatial location, about your habits, about the way you drive your car, about all kinds of things. But I would say those are really some of the big drivers. Of course, social media and genomics are big, but surveillance and RFID chips and sensors are really the two biggest ones when we look at the data that's driving the data growth. With that said, there's really a few implications, right? It requires new platforms, meaning, if you're going to do this kind of large-scale work, many of the more traditional platforms and databases aren't really up for the job of doing this. There's new roles, and I think that's a lot of the work that you've been doing and the training you've been doing around data science. Certainly, I think this is forcing a lot of people out of their comfort zone, pushing people to learn new areas, and sort of be more interdisciplinary in the way they approach problems. And the third is there's certainly new techniques, there's new algorithms, and there's new ways these are being applied. So, I'm just going to very quickly show a couple of different kinds of data structures. One that people are used to looking at the most is very structured data. This is really about 20% of the data that's out there. When people talk about the big data growth and how much data is being created, this is the 20%. The 80% is all the other stuff I'm about to show you, right? That's things like semi-structured data, which is what's the XML that sits behind a website, or other things that have a discernible pattern that are pretty regular but require more work to parse them, read them, and analyze them. Then you have things that are kind of what we would say is quasi-structured, right? So if you go to Google, here I'm just entering the term data scientist, and then if you hit enter, you'll get all these hits, but your search bar will give you something more like that, right? Instead of being google.com, it'll be this long string of gibberish-looking stuff. But that gibberish you can actually parse and make sense out of and understand what your web browsing habits are, what other websites you go to, how long you're spending on these sites, how long you've spent in that session. And this is actually something that has become a bigger and bigger deal. As anyone who's followed things like the PRISM scandal with the NSA recently probably is well aware of. The last one is really unstructured data. There's a lot of things that fall into this bucket that I'm not touching on. But as an example, text, poetry, literature, that falls in this category. The other is things like video footage. This is a picture of Jonathan Harris. He's actually a data scientist and storyteller. He's fantastic at sort of mixing these things together. But the reason I say this is there's really different kinds of data structures. They require different approaches to conditioning them and being able to work with them. And typically they call on different kinds of algorithms to analyze them. Okay. One way I think about this is also there's a lot of opportunities for new approaches to analytics. So within this, there's kind of a new ecosystem or a new economy emerging around big data. Certainly I've talked at the top level around data devices. These are many, many things that have intelligent sensors or chips in them to catalog, store, and track information on certain kinds of activities. So these are things like your cell phone and GPS, like I mentioned, but also things like your cable box, or things like your ATM, or video games, I think, or ebooks, I think are pretty interesting examples of how this is being done. So For instance, your cable box, is also a kind of recommender system. If people think of Amazon as recommending books, but your cable box will recommend shows to you. It will decide what kinds of ads to show you. It will decide what kind of coupons to show you for free movies or TV shows based on other things you've been watching or other things that you are pausing on and looking at, choosing not to watch, right? So even those things are recording your preferences and behaviors and habits. Then you have things like data collectors. These are groups like government, internet, retail. A lot of these organizations are collecting all that sensor data and trying to do interesting things with it to draw out insights. Then you have data aggregators. You have a lot of people who are, if you turn the clock back 10 years or 20 years, you really have a lot of marketing list brokers. If you're going to do a marketing campaign, you would go to one and you'd say, tell me all the lists of, directors of IT, and I'm going to mail them something or I'm going to do a calling campaign. Well, now these people instead will go and, buy data, or they will aggregate data that they can turn around and resell. So, instead the data itself is becoming a commodity that has value that people can sell and try to monetize. So I think there's a group there that's trying to do exactly that. And then this most outer ring, you have people who are using it and buying it, right? So that can be, investigators and lawyers, that can be banks, that can be law enforcement, these people who are really consuming all the things that are in the earlier layers of this ecosystem. To say the least, industries are very, very broadly embracing data science. There's a lot of applications for this. I always think traditionally financial services was an early place to adopt this. Oil and gas research is another. But financial services, right, they have things like algorithmic trading, high-frequency trading on Wall Street, where they're doing very, very, very high-throughput number of trades, hundreds or thousands or millions, and they're doing it in near real time. They're doing it in microseconds. There's a great video that got popular due to iPad ads, and it was a TED Talk called How Algorithms Shape Our World. And it's a great talk. If you're interested, I'd suggest it. But one of the things they talk about is they say, what's your life like if you're an algorithm? Well, you probably do this kind of work. You probably are responsible for, analyzing these kinds of instructions sent to you. And he said, well, what's your life like if you're a Wall Street algorithm? Well, if you can process trades in 30 microseconds, you're a loser, right? You have to be able to do it in 3 microseconds or 4 microseconds, right? It's so incredibly rapid, and getting that latency shaved off is the difference between, thousands or millions of dollars in, hedge funds or pension plans. So these people have been doing this kind of work actually a long time. And there's a lot of wealthy data scientists working on Wall Street, certainly. But there's a lot of other areas, right? Smart grids and energy. Government is doing a huge amount of information there and a huge amount of analysis there. Some of it's become more public recently, but they've been doing this a long time. Healthcare and life sciences, I think, is actually a place where there's tremendous opportunity, and there's a lot that's being done there, and there's still a lot more to do. But that's actually a place that people are trying to get smarter about electronic health records, about predicting who is going to have an illness, and therefore what kind of costs are associated with certain kinds of illness and certain kinds of people who have certain kinds of risk profiles. So there's a huge amount of research that's being done there. So some of the needs for this, and I think of this more in a commercial area, but it's happening in other areas as well. Certainly there's a desire to optimize business operations. So I think this is like sales, pricing, efficiency, profitability. I think this really in a more commercial setting perhaps than here. But I think universities have these same questions and problems like the rest of the world, but the problems are slightly different, right? Like there's a VP of HR that I work with at EMC, and he's an economist by trade. So he would say, people look at likelihood to default, they look at loss prediction. He said in HR, we have the same problems, but the problems are framed differently. So instead of, likelihood to default, he says, I have the likelihood to lose a certain employee. Or instead of, loss analysis, I know what is the turnover rate and the churn, my employees in certain divisions. So, he still approaches it like an economist, even though the nature of his problems he's looking at are HR-related problems. I would encourage you to think like this, right? Think about, these may not be the same language that you're used to using, but you probably have problems that fit in these areas, I would guess. So areas like business risk, what does risk mean in this context? I don't know. That's probably a question for you, Chris, to answer more than me. But certainly I see this a lot in many, many businesses. And there's ways to measure things that are intangible. And I think that's when this becomes much more interesting. Certainly predicting new business opportunities. Amazon is famous for this, right? Figuring out if you liked A, what will you like that's B? What are the other things I can offer you? What's the other things I can show you that are likely for you to buy or click on or consider buying? And I think the other that's really a big one is compliance with laws or regulatory requirements. A lot of organizations, particularly banking, healthcare, government, a lot of these areas have very strict rules about how they store and manage data, how they share data, and increasingly and what the security and privacy aspects are related to that as well. So just to level set a little bit on analysis, I think there's so much written about data science and analytics that I just wanted to take a quick second to distinguish these things a little bit. Very commonly there's business intelligence and data science, and people kind of mix these things together. It used to be that this horizontal axis we would think about as a time horizon, and the vertical one we used to think about as like value. Right? Data science projects tend to be more valuable and more durable than some of the BI projects that get done. But I think I don't want to marginalize what BI people do, because what they do is certainly valuable. So instead, we kind of think about it like data science can be a little bit more exploratory in terms of the nature of the projects that they tend to do, whereas BI projects are a little more explanatory. So what I mean by that is BI, I think the best litmus test for many of these are the sorts of questions you can ask, or the kinds of questions you can answer. So this tends to be more structured data, and I think more traditional data sources. So it's things like reporting, dashboards, queries. These are generally like the more traditional big database kind of thing, where you're asking a question, and typically a more closed-ended question, and trying to get an answer to that. So these are things like what happened last year or last quarter, how many of a product did we sell, how many books were checked out on this topic, where is the problem, under what conditions, can we isolate these sort of patterns? And data science is quite a lot more open-ended, okay? So I'm using data science to cover areas like data mining, predictive analytics, statistics, applied math, operations research. It tends to be sort of the mashup of all these things together. A friend of mine likes to say that it tends to be someone who knows more statistics than engineers and more engineering than most statisticians, meaning you're kind of this hybrid, kind of a little bit of a hacker mindset, people who can take kind of messy things, they're not afraid to roll up their sleeves and get it into a shape they can work with, and then they also know something about quantitative methods, and they can analyze it. So this tends to be lots of things, and the data types tends to be varied. So this can be text, it can be structured data, it can be video, it can be any of those big data sources I showed you earlier in the presentation. And the kinds of questions I think are more like the what if kinds of questions, right? Or the what's the optimal scenario given this situation, right? And how would I figure that out, okay? Or what will happen next? One of the other ways people tend to distinguish the BI and data science is BI tends to be a little more rearview mirror sort of thing. Like, people say this is like hindsight and insight. It's what happened in the past, so I can get a very clear understanding of it, and a little bit more of what's happening today. How are we year to date on this metric, or if we look at our business or our company from this way. Whereas data science is sort of the opposite. It's like insight about what's happening today and foresight about what's happening in the future. So if I see what's happened in the past, what can I say about the future? If I see what's happening now, what do I think will happen in the future under similar circumstances? So if we talk about tools and technologies and skills, and I'm going quickly so we can have time for Q&A, but I should also encourage you, if you have questions, to interject and ask. But I guess sort of like Kago was saying, I do really believe this is like a team sport sort of thing. Not everybody needs to be a data scientist, and maybe not everybody wants to be a data scientist. But there's certainly a different set of roles that are a little broader that I think has to be present for these projects to be successful. And this may or not need to be 7 different people. It may be 4 people. It may be 25 people. But I think a lot of these same roles and the needs for these roles get met. So, you need a business user. You need someone who knows the domain really well, right? You need someone who's ultimately, sponsoring that project and saying, yes, you should do that, or I'm going to fund that project. Certainly you need to have someone who's, a little more operational to make sure things are getting done when you need it to get done. You need BI analysts because they know the data very, very well. And they typically know the data sources really well, them and the database administrator. And I think these 2 roles are really the ones people are the least familiar with, right? And data engineers tend to be different than DBAs. DBAs maybe are, maybe they're better at provisioning a database or giving access privileges or figuring out the systems where it should be run. But data engineer may be someone who's really excellent with SQL and really knows how do you manipulate data and how do you write really high performance queries, or how do you work with very large NoSQL databases. Whereas a data scientist, they will do some of that, but they may be better with figuring out kind of the experiment design and the analysis of it and the visualizations from it that will let you tell a story with it. This make sense? Yeah? Okay. All right. So, I'm going to just do a very quick overview of this life cycle. I think Chris sent out a link to a blog series that I co-authored about this, showing an example of the innovation project that I showed earlier on in this presentation, but really breaking it down into these phases to say what was done in each one of these phases and how do you understand how to apply this life cycle methodology to projects like that. So, I was surprised when I developed this process that I found there was surprisingly little written about processes for data analytics or data science. I mean, really, I was incredibly underwhelmed when I started doing research in this space. There was very, very little. So I actually built on certain things and created our own out of it. So one thing, obviously, to start is, I would say this is very skewed. It's not to scale, so to speak, right? Even though we have 6 things, you heavily spend your time in the first 2 phases, in discovery and data preparation, right? Discovery, I think I've worked with a lot of people who they don't really like doing those parts, so they tend to skip them, and they start to jump to here. They want to start planning the models. What are the cool things we can do? Maybe we should just start building it and figure it out later, and they do. And then they wind up having to slide back and ask the same questions that they could have asked in the beginning, right? So they kind of jump ahead, but only to sort of slide back a few phases. So I would say be very thorough on the discovery phase, meaning be very, very thorough in understanding the problem very well, right? Typically, I would say you hear about a problem and you want to try to convert it into an analytics challenge, meaning how do I reframe what I'm hearing and write it down in a way that I agree with the stakeholders, the other people have a common understanding of the problem, and we can think of ways that we can test these ideas with data and with analytics. Then we have data prep. I would say in a project, data prep is conservatively 50% of the project, but probably more like 75% of the time spent on a project. So when Chris and I were talking earlier this morning, if library staff or people in this room can get better at this part, this is part that a lot of people really like doing the algorithms, and they don't like dealing with this part. Although there's a huge amount of value in that part. So I would guess if you can get a lot better at this piece, you're going to have a lot more people knocking on your door to partner with you to do projects. Right? This is a hugely valuable part. And increasingly, what's happening here is people are recognizing that it's not this isolated, separate activity. It used to be that, for instance, I used to work with economists at the Federal Reserve to look at housing prices and mortgage prices and mortgage approvals, and statisticians who were good in that space. And what would happen is statisticians would say, well, just give me the data, in this exact form, and when I get it, I'll start doing my piece, right? Like it's a relay race. And invariably what we learned is real life doesn't really work like that. And the people who gave you the data extract decided certain attributes were important. And they may be very different than what you think are important. So what's happening is in the data prep, it's not just about conditioning the data. It's also about determining which features of the data are important for you to later analyze. And this is actually a critical shift. And it means that the person who's involved with the downstream analysis needs to be involved with the upstream work too. Because they're going to have some voice into what are the important features, what are the important parts of the data that you need to scrub and get into shape that are going to be very useful later on. This makes sense? Yeah? Okay. So then you do things like model planning. The way I think about model planning is, what kind of models can I try in this situation? So you may not have picked an exact model, but you probably have ideas of which ones probably make sense. So you may say, well, I don't really know if it's going to be a logistic regression or a decision tree, but I'll probably wind up choosing a classifier of some kind for this problem. So, and I think the first one we should try is this one, and if that one doesn't really give us good results, I'll try, these other two. But you at least know sort of the category of algorithms that you can try in a given situation. And then, of course, you build it, and that's really where I think most of people's attention is spent is how do I build the cool model and do these cool things with it? But ironically, you spend probably the least amount of time there. That's actually kind of the quick part in many of these projects. Then communicating results. Communicating results is really hugely important. And I would say a lot of people I worked with in the past typically view this cycle as phases 3 and 4. How do I figure out what models to do, and then how do I run them? And unless you do sort of the pieces on both ends, you're not really getting the value out of doing this well. And the reason I say that is you have to do the data prep and the discovery, but you also have to communicate the results. So the reason I say that is if you do a great project, make it about the work. Trumpet your wins, but make the wins about the work that was done and how you're driving progress. And this is how you drive change. This is how you get people to understand that you're driving value and understand that you can have more projects like this that are high value to your organization. This is important. And I think at one point I really underestimated this. Like the innovation project that I showed you earlier, I'm amazed at how much this has been evangelized. I mean, I wrote a blog series of 16 blogs about it with another person at EMC. It actually was written up in Business Week last year. We were contacted yesterday by researchers in the US and in the UK who want to do a follow-on research project with us to expand it by reading what are the tweets that those people in the innovation contest are writing about. And can we infer, based on the diversity of their social networks, who has more attributes of innovation? And therefore, from that, can we predict how well they're going to fare in different circumstances? So, I mean, you can take this stuff pretty far, but I would also say you have to let the world know you're doing interesting work, too. And the last thing is operationalize. So by operationalize, I mean you're not just doing this one-off project on your desktop. Many organizations are saying, well, that was kind of my proof of concept or my pilot of figuring out, can this work, right? But then you're figuring out ways to wrap it, put it in production, and make it more high-performing. So an example might be you might write an algorithm using R or using Python. But if you were going to put it into your production environment, R might not be the thing you would use in runtime, right? You might use it in Greenplum or Netezza or some other big NoSQL product or platform, or you might use something that's going to give you very high performance, depending on what you're ultimately going to want to do with it. And that's kind of where this is going. It's going from doing really interesting projects on your desktop, which are still valuable, to making it so that you can automate many of these decisions in near real time using very high-performing systems. Okay. I think one of the other things that's really changed a lot are the data sources for these kinds of projects. So if I look at a typical organization, typical company, they have these kinds of areas. They have HR and finance departments and R&D departments. They have sales areas. And typically they have their own kind of stovepipes of data that they're used to working with. So in HR, maybe that's their appraisal system, right? Or their training records. In finance, maybe their sales leads and their ERP system, their resource planning systems. But the reality is there's a lot more out there in the world. So if I just stick with HR for a second, there's also salary surveys that are out on the web. There are job postings that are on the web. There's sites like Glassdoor that you can go to and you can get anonymous people talking about their experience working at different companies and what they're being paid at these companies for certain kinds of roles. So it means that suddenly, you can get a pretty good idea as to what's a reasonable pay range. You can get an idea that's, was someone really happy working there, or why not were they happy working there, right? Same thing for, LinkedIn or data.gov, Zillow. Many of these have APIs that you can use to plug into other applications and then mash these up and use that data in near real time to make decisions. Zillow is an interesting one where, are people familiar with Zillow? Yeah? So, one interesting thing about Zillow, people are trying to say, well, instead of waiting if I want to apply for a home mortgage loan, and then applying, waiting for the bank to tell me yes or no, and then going to do an appraisal, and wait 30 days, 60 days to close. Well, I can use some of this stuff and I can get an answer, in an hour. And I can know pretty quickly, are the home prices in that neighborhood going up or going down? If I compare it to things like, freely available data on crime rates and demographics, what does that tell me? How about how good the schools are? Well, I could look at MCAS data and figure that out. MCAS isn't perfect, but it's one benchmark. So there's a lot of freely available things that you can use to combine and get answers to questions that are otherwise, traditionally slow or difficult to get answers to. So again, I don't know what those data sources are for librarians, but I'm sure there's a lot of other ones that are freely available. Blogs are actually a great site for many of these things, right? You find blogs. There's a Jonathan Harris who I showed in the earlier screenshot of him on video. He wrote this book called We Feel Fine, which is a really interesting idea for a project. And what he did is he wrote an algorithm that basically hunted the web for any time someone said, I feel or we feel, and said, what do we feel? When do we feel happy? When do we feel sad? When do we feel alone, right? And correlated that with things like weather patterns, their geospatial location, the days of the week, what they talk about, and then did things like cluster analysis of the emotions. Well, when someone says they feel happy, it means they feel contentment, they feel peace, whatever. When they feel angry, they feel these other ancillary emotions. And the people who are happy, they tend to live in these cities, and they tend to say that with this kind of weather, and they tend to do this kind of work. So it's almost like a coffee table book. It's very visual. It's actually emotionally very powerful because he takes all these emotional statements and pictures and then also analyzes them too. And it's quite interesting. But blogs are a great source of this stuff. He basically used the internet as a corpus to do this kind of text mining at very large scales. This is not all the tools out there in the universe, but this is some of the popular ones to do some of these things. So I wanted to just highlight some free and open source ones and some commercial tools in this space. So for statistics and data mining, certainly R is very popular in RStudio and those kinds of things. But there's others that are free. Weka is very popular in academic settings, as is RapidMiner, probably less so. Octave is a little more like the free version of MATLAB, which is really used for machine learning and a lot of statistical analysis. And I know you had said you're using Python. Are you using NumPy or SciPy or any of these things?
Yeah, we briefly go into it.
Yeah. Maybe just scratching the surface, probably.
All these guys are. The astrophysicists are.
Yeah. And then, of course, there's a lot of commercial tools, right? Mathematica, MATLAB, SAS has been around forever doing this kind of work. And I think for things like NoSQL, certainly Hadoop is very popular. It's getting a lot of visibility and press. And the other thing that's happening is creating an ecosystem around Hadoop. So instead of it just being this thing that does MapReduce, people are using it to parallelize data ingest, right? They're taking hundreds or thousands or millions of sources and finding ways to parallelize the jobs of parsing it, making sense of it, and bringing it into a data store. The other thing that's happening is people are building things like Pig or Hive on top of it, so you don't have to be a great Java programmer or a Python programmer, and instead you can find ways to write SQL, which is something most people are a little more familiar with it, and have it pass instructions to Hadoop and give you answers to complex problems. Of course, there's other things here, Postgres, Greenplum, Mongo, and a lot of commercial ones. Greenplum I have on both sides because Greenplum has a free version and a commercial version, and some of these others do as well. But Oracle, MapR, Teradata, there's many more I'm not listing here just in the interest of space. And then of course in natural language processing, I would say this is also, has been around for a while, but it's getting more popular as there's more data available to analyze and to mine and make sense of. So certainly like the Stanford NLTK is very popular, Python's NLTK, and then of course there's others, Cogito, Dragon, there's many others that are commercial, and of course like any of these things, with commercial products you get more support and more guarantees of reliability and all these things, and open source, well, are free, which is nice and I like, and also has a very strong open source community related to it, but it's different. You're also doing more of it yourself in many ways. So I know you said people have used Python. What else was in the first course? Was R in the first course too, a little bit?
Yeah, there's R, and there's OpenRefine.
OpenRefine, yes.
Tom Morris is here.
Yeah.
And then there we did Tableau.
Oh, okay.
We went through the whole process, the sort of data lifecycle process, and touched on some tools from different points. So, we never went too far into this realm because I think that's a good point to start at that level. And, know this is here. This is why you're telling us that.
Yeah, good. Okay, so just a few more, and then maybe we'll break for Q&A. But certainly, there's been a lot written about the growth of data science roles and roles related to big data. As I mentioned, it's not just about data scientists, right? I see a huge volume of job postings and a lot of recruiters contacting me about big data architects and about people who are NoSQL architects, because it's not just people who can analyze this, people who understand, how do you put the platform together, how do you manage the data, and do it in a purpose-built way that it can be analyzed well later on. But there's been huge spikes of this, and I've updated some of this more recently to see what it looks like in 2013. And some of this, the spikes are still extending, although I think as the economy slowed down a little bit, there have been fewer new job postings, so it's still increasing quite a lot, but it's tapered off to some extent. This is from a McKinsey study. I don't know.
It's on my slides too.
Is it?
Show it now.
So the McKinsey study, they talk about shortage of people with talent in these areas of statistics and machine learning, and I really do agree with it. This is a very good study. It's free. I will commend McKinsey for doing that. A lot of their studies are not free, and this one is pretty sizable. It's about 130, 140 pages. And the other thing they do is they talk about a lot of use cases in different verticals. So they'll talk about healthcare, telcos, government, and give pretty good explanations as to what are the opportunities, and of these verticals, which ones are more likely to be early adopters and why. So that can be availability of data, can be availability of skills, or it could be availability of, say, funding and understanding in that space. So I actually think they do a really great job of this. They talk about shortage of people, who are data scientists, but also I would say people who are just, data savvy, not necessarily even data scientists. And I would say even just being data savvy is extremely valuable, and you're probably still farther along than most people who are not. So just to put it in perspective a little bit, I would say a lot of IT people and DBAs, they tend to be in this kind of bottom one. They're kind of data enablers, they're technology enablers. They're doing things to create analytic sandboxes and workspaces that people can go and do these complex problems or experiments. Their study really focused on these top two levels, right? And it was just also bound by the U.S. It wasn't a global study. So they said in the U.S., the talent gap there for data savvy professionals was about 1.5 million. So these are data savvy managers or analysts who've taken at least a class in statistics or machine learning. And obviously the top level are data scientists. So these tend to be people who have PhDs in economics or astrophysicists or mathematicians, people who they're very, very deep in these areas. And I mean, it's about a tenth in terms of the shortage, but there's still a lot of people. This isn't the number of jobs, this is saying the gap in terms of what we think can be filled by 2018. All right, really, I'll go quickly through this. So just a quick profile of a data scientist. These people tend to be quantitative, right? They tend to not run in the other direction if you show them a formula or two, or they may even enjoy kind of working with data and working with numbers. And they tend to be reasonably technical people, meaning they're not afraid to use tools that are not just GUI-driven tools, right? They're not afraid to write some code in Python or R or what have you. And when you can do these two things together, it means the universe of data sets that you can work with suddenly explodes. It gets a lot bigger. And earlier I said that the kinds of data sets that are really growing are the non-structured or semi-structured data sets. So these are ones where tools like OpenRefine or Data Wrangler or Reshape and Plier within the R context are very, very helpful for conditioning the data. But it also means if you have some balance of skills in these areas, you can tend to write algorithms and analyze it too. I tend to think people are fairly skeptical in this area. And I don't mean kind of negative, but I mean critical thinkers, and they ask a lot of questions about the feasibility of some of the solutions, right? And they tend to be pretty good collaborators and communicators. So I typically think this is the difference between someone doing something cool in their basement versus like driving change and evangelizing big wins or big projects, or being able to work with lots of different kinds of people on a complex project. And the last is they tend to be pretty curious people, pretty creative people. I know a lot of these people, which is fun. I mean, my wife commented to me recently when I tell her about some of the people that I've met that they tend to have much more interesting hobbies than other people that I've worked with. They tend to be people who, they're master fiddlers, they're beekeepers, they're, bicyclists, they build all kinds of things. It's just, I think the diversity of the interests and the people, really is pretty broad in this. It's people who are just interested in lots of things. One of them happens to be getting insights or getting answers to different kinds of problems. And the way they go about doing it is through analytics or pretty unusual visualization methods. So I'm also showing this because if you're doing a second data science course, I think a lot of it is just the mindset you have to cultivate if you want to get good at this or you want to be in this area. So, the kinds of students that have come to the courses that I've taught, they tend to be recent STEM grads, science, technology, engineering, and math. People who are maybe, in their early 20s, but they have some background in these academic areas based on their formal training. Or they tend to be BI and IT professionals, so they're reasonably technical, but they're not very quantitative. So they're used to provisioning an Oracle database, but they don't really know how to analyze all the data, or they've never really taken the time to learn how do you really condition data well. And then you have sort of the opposite, people who may be data analysts or business analysts, so they're very comfortable doing reports or visualizations or some analysis, but maybe they're less technical, which means that they can do a lot of great analysis, but the kinds of data sets they can work with is a little more restricted. And of course, data scientists tend to be a good blend of both of these things. So just a quick overview of the course. The first course I developed really for practitioners. We do more of an introduction on big data and data science. They give a lot more examples about that. And we do a much more in-depth look at the analytics lifecycle. Here I did it in a slide. In that class, we probably spend 30 or 40 slides doing that, and we probably spend over 2 hours just talking about some of the tools you use in each phase, some of the activities you do, some of the right questions to ask, and a lot of examples about how do you know when you've completed each section. To me, the best litmus test is really the kinds of questions you can ask, because I don't think this is a stage gate. I'm done with step 1, I'm in step 2. I don't think life is really that clean and cut and dry usually. Usually it's more like I need a gut check of, well, am I out of phase 2 and into phase 3? Well, how would I know? Well, I could probably answer this and this. Okay, then I'm probably there and I can probably start doing the next set. So I think that's generally a good sanity check. We also teach some, we say, basic methods. A lot of people who come have background statistics, but it may have been 20 years for them. So we take the opportunity to teach them a little bit about R, but also refresh some things maybe they've learned in these areas. And then we teach them some more advanced things about machine learning and data mining, predominantly using R, but also doing text mining with things like Hadoop or Postgres. So they get practice doing a little bit of each. And it's very lab-oriented. So it's not just people lecturing all day, every day. It's about 50-50 labs and lecture style. And of course, we have certification exam for this as well. And I guess one thing to mention is this is all using free and open source tools. And what we really want is people to learn this and then go off and be able to continue learning on their own and get better at this. This was really the course I was talking about at the bottom. That's actually a week-long course. We also offer it to universities who join our academic alliance programs for free. And many of them teach it. Some local Boston schools have taught it, but we have about 1,500 schools worldwide that are part of this program, a couple of hundred who've started doing this. These two are the more recent ones we've done. We realized after doing this that it's not enough to sort of educate people who want to be practitioners, but you also have to teach people who are, managers, directors, leaders, because ultimately they're going to answer questions of, is this worth me spending time on and caring about or putting money and people on? And if so, what are the kind of opportunities that we can go conquer by doing that? So we teach them slightly different things in terms of, overview of a few algorithms, more from a business level perspective or a layperson's view, but also things like, how do you build a data science team? How do you drive innovation? How do you drive change? What are ways that you can do that based on research? This is a little bit about the Academic Alliance program I mentioned. I won't spend too much time on this, but if this is something you're open to, please come talk to me. I can certainly tell you more about it. And it's a free program, and we share all the curriculum and supporting materials to do this. I guess the other thing I would say, I think I have like 2 more slides here, but the other thing I would say is there's a lot of ways you can learn that I think are really excellent ways that are not formal, right? So it's not just sitting in the classroom. So certainly there's the courses I've helped to develop, but there's a lot of other STEM-related graduate programs and certificates. There's a lot of conferences in analytics. So Informs does a lot. Informs is a society based in operations research, which is really excellent group. Also Strata. Strata does a lot of worldwide conferences. They do another one in New York this October. They do it twice a year, one in Silicon Valley and one in New York every year. And that's really about sort of the, really for practitioners to learn new methods and to learn about sort of how's this field advancing across different areas. And that's actually quite an interesting one. Predictive Analytics World is actually, that's PAW up here. That's actually going to be held in Boston in another month or 2. And that's also a pretty good size conference. But even if you don't attend these conferences, many times they'll post the presentations for free online. And if there's a certain topic you're interested in, like text mining or regressions or Hadoop, you can read about those things there. And then you have MOOCs, right? You have these massive open online courses. Coursera is great at this. Harvard's part of edX, right, with MIT. There's a lot of these Khan Academies around, right, that's a little bit different. But these are huge. Like Coursera has a lot of related courses. They have some on R programming. They have some on machine learning. So these are free. They just take your time and focus to get through them. But they're free nonetheless. And they're self-paced. Well, quasi-self-paced, I should say. But I think these are excellent. As a friend of mine who's a data scientist at CMC says, he can't decide if Coursera is the best thing or the worst thing because, it's free, it's fantastic, the opportunities to learn are really great. He's taken a bunch of them, but if he's not careful, he'll spend all his time taking courses and learning new things because he likes doing that. So you have to be tricky, or a little discerning about it, I should say.
You know what happened with our first course is that some of the students said that they didn't want to stop coming, like that the physical part of it was kept them going, and in a Coursera they would stop.
Yeah.
They would only look at the first 2 courses or first course, and the whole camaraderie, I think, of the training was keeping people in the course.
Yeah, that's a huge part of it. So Coursera has recognized this, right? I mean, they're smart about this too. They analyze how people try to learn. So they've noticed that about 75% of the people drop out. after a few weeks and they don't complete the courses. But what they've done is they've tried to create meetups, Coursera meetups around certain courses. So they'll try to have online meetups. They'll try to have in-person meetups in certain cities to help people. There was a group that formed around Boston for the machine learning. So the machine learning course and then subsequent meetup to help people do it. But I think that's a big part of it, right? I did a course on R programming about a year or so ago through Coursera. I wanted to try it. And I have to say, it was great. I'm in a great position because I work with a lot of people who are great at R. So if I was stuck, I could go ask them and sit and talk with them, and that actually helped me get through some of these. So I think there's actually a need to supplement these with, mentoring, coaching, and those kinds of things help a lot. Absolutely. I was just going to say, informal training, I think there's a huge number of opportunities to try out your skills, right? Again, that innovation example I showed earlier that we did at EMC, that was by someone who, he'd taken some of these Coursera courses and he wanted to try out his skills. And he saw that as an opportunity to drive value for EMC, but also let him try it in a more real world context. I would guess there's a lot of opportunities here for you to try to do that too. You just have to kind of jump in and be willing to try it. But just like I showed skills gaps, most groups that I know are really hard-pressed to find people who are good at this stuff and interested and are willing to dedicate a little bit of time. So if you're wanting to raise your hand for it, most people are wanting to team up with you, and there's a lot of opportunities to do that. I don't know what you think about it in the space that you're in, but at least where I am, I see lots and lots and lots of opportunities for that. Social media is another huge one. For me, these are things like meetups. These are tweets. LinkedIn has lots and lots of groups on big data and on analytics. I'm probably part of more that I can keep up with at this time, but a lot of them have useful things. So I do get occasional news feeds from them or discussions around analytics. This is a great way to learn and great way to find out about other resources to help you learn. Twitter, I used to think was really just noise and Justin Bieber and that sort of stuff. But I realized that there's still plenty of that, of course. But it's not 99% noise, it's maybe 95% noise, right? It's still, if you can figure out who to follow, I was actually really happily surprised to find out there are a lot of people who are heads of startups. There are people who are professors at universities worldwide who are on there who write about research they do. They write about admissions season for their university. They want people to collaborate with, right? So it's, again, like a lot of these, there's such a deluge of information. If you can be a little discerning about who you follow and what kinds of topics to follow, there's actually a lot to be gained and a lot to be learned here. So this was a shock to me, how useful Twitter can be for some of these things, both in terms of who's publishing and who's writing and who's putting pointers to research, but also to use Twitter as a data set where people are actually using the Twitter API to get data out and test lots and lots of ideas. Another researcher I know at Penn State, he used this to predict the spread of epidemics worldwide and in the United States, and also correlate it to vaccines. So which parts of the world and which parts of the United States were not getting vaccines, and what were they talking about? And what are the relationships there with socioeconomic factors to figure out in what part of the United States they have to do public service awareness, right? To try to convince people why they should do vaccines. Then there's areas to volunteer, like DataKind. DataKind is a group that used to be called Data Without Borders. They basically have all these like charitable projects and free volunteer projects, and they need people to help out with conditioning data or analyzing data. And these really range. These are, help us analyze the quality of the water for a city, to tell us the best routes in cities, to help with traffic patterns and urban planning, to, we have 4 death row inmates who believe they're innocent. Can you help us analyze the data to help prove it either way, right? Just all kinds of projects, and they need help. And then, of course, there are contests like Kaggle and Innocentive. Innocentive's a lot like Kaggle, that basically they crowdsource analytics problems and people can earn money to do it. If you look at people who are the top Kaggle participants, these people are doing lots and lots and lots of competitions and making money doing competitions and getting lots and lots and lots of job offers for showing that it's not just on their resume, but they're showing they can do this, right? This is evidence they can do this stuff. Okay, so I guess the main takeaways I would say are big data provides a lot of opportunities for deriving new value, new insights. But to do this, you really have to step up to challenges and opportunities. You really have to be willing to take some small risks, push yourself to learn new things, and try to experiment with some of these data sets. And find ways to grow your skills, right? I gave a lot of examples of ways to try to do that. So, kind of real closing thoughts, right? We talked about these examples of tracking innovation networks. We talked about New York Stock Exchange. We talked about some of the sources of big data and this ecosystem around big data, and also the life cycle of how do you do these projects. And I'll show you links to how you can read more about this if you haven't done so, if you'd like. I think MOOCs, online learning, are a great source of this. Even if you don't go all the way through it, starting to do it or getting more familiar, I think is very, very helpful. So I guess I would just let you think, what are you trying to do? Are you trying to map like the idea flows in literature or in research around certain topics? Or, you look at citation networks so you can find who are the most influential researchers, who's driving thought leadership in different disciplines. Or, I've read research about people who are able to predict award-winning papers, right? Which papers in a certain contest or a certain forum will be the best. And what do you mean by best? How do you figure that out, right? Or just have more collaboration with researchers and faculty. How do you do that? Is that a goal? So I think part of it is figuring out what are the goals and how do you want to try to get there. And for me, one of the more interesting things is just to challenge traditional thinking. Most people I know, they're based on habits. It's a great book that was written called The Power of Habit. I don't know if people know this book. Do you know this book? No? And, a lot of people wrote about, the famous example at Target, where Target's able to predict which of their shoppers are pregnant, sometimes before their families know they're pregnant, right, and make money doing that, but also things like more everyday habits, like, you take the same set of habits in the morning before you get in your car and drive to work. And then weird things happen if you're not paying attention, right? If you always put your keys on the coffee table and you go to pick up your keys in the morning and then you get your wallet and you get in your car and you go, well, sometimes if you put your keys out, you'll start driving to work on a Saturday because that's the ritual you've done, right? It's the ritual you've gone through to get your wallet disordered and get your keys and get your coat or whatever. So the same thing happens in our day-to-day jobs, right? There's certain habits you have and certain things you do that are cues for how you make decisions. And if you start doing analytics like this, it will challenge those habits and will challenge those ways people are used to making the same decisions on certain topics. So I actually think that is a really interesting and valuable thing to do with this. These are just some links. This is, if you want to find me on Twitter, that's where you can find me. And this is areas that I blog or where we have resources about these topics. And that's really my last slide, I promise.
Wait, you can take like one or two. I'm going to set up one or two questions right now.
Okay, sure. So I don't know if there are questions. Do you have a mic you gave out or not?
She's got the
mic. Does anyone have questions they want to ask about based on anything that I talked about or work you're doing? No? Yes?
Most of the sources you were talking about are social media and stuff, but I mean, are there issues with copyright ever? Like, where sources of data that are kind of not okay to tap into?
So that's a great question. So you do have to look at that. I think it gets interesting. Typically, if you're going to look at it and analyze the data, there's a huge amount of data available. I think where it becomes a little trickier usually is if you intend to profit from it. If you want to take someone's data and package it and resell it, there's other restrictions around it. And they usually tell you the kind of licensing. But things like social media data, like Twitter data, if you're going to run experiments, you're going to create models with it, typically that's fine. If you're going to take that data and turn around and resell Twitter's data, then typically you have to talk to Twitter. But people are doing all kinds of things with Twitter, as an example. There's also things like, if you're on LinkedIn, you can download your LinkedIn network, and you can look at what are the relationships among the people who are in your LinkedIn network, or Facebook is famous for that. There's a lot of these sources. I would say from my standpoint, Twitter is probably the fastest growing area that people are using to test ideas and do experiments. I really just, for a long time, held out and didn't bother with Twitter because I just thought it was, people saying I'm waiting in line for a latte, or this sort of like, mindless commentary, so to speak. But I'm really amazed with how far people have taken Twitter for scientific research and experiments. Really, really amazing. I've seen people create algorithms to analyze Twitter and then predict moves in financial markets and stock markets, right? I've seen people do it, as I said, to predict academic or epidemic outbreaks and vaccinations. I've seen people look at the social graphs and social networks that people have to make predictions about certain things. People are actually really taking it far. I was in Singapore about a year ago, and there was a tsunami warning. I couldn't get much on a live news feed on the television, but I could get people up and down the coast of India and parts of mainland China talking about weather patterns and what the storm seas were like. So, there's actually a lot you can glean from some of these things. Yeah. I don't know if that answers your question or not. Yeah.
I actually have a follow-up question. Well, it's slightly different, so I don't know if nobody else has any questions.
Yeah.
But I remember seeing in Boston.com or something recently, and it said, the more ice cream people, like the days when more ice cream is consumed in the country, the higher the rate of suicide. I kind of, I looked at it, I was like, well, that's interesting, but is there a time when you feel like, you never know what data you need, but at some point do you say I do it because I can do it, or is, what's kind of the point of that?
Yeah, there's a lot of both. That's a great question, actually. I think sometimes people are doing interesting things just because it's there, kind of a thing, like climbing Mount Fuji or something. But, I think a lot of it is back to kind of the discovery and problem definition. If you're really saying, well, the best way to analyze this problem is with this kind of data, and many times it's a blend of data you've got and data you don't have, then the question is, where can I get data that's publicly available that will supplement what I've got and give me a richer analysis? So sometimes I see articles people write, and it's more like factoid than research to me. And then other times people are doing pretty interesting, unexpected things with it, I guess. Yeah. Like the Hubway, I don't know if you know the Hubway bikes around Boston. They had a Hubway challenge. They posted all the Hubway data. And all the Hubway data was things like all the stations, all the Hubway stations around Boston, all the Hubway bikes, all the traffic of when people have rented bikes and checked them in and checked them out, every timestamp of every bike, everything. And they made a challenge to the city, and they said, anybody who wants to analyze our data and tell us something on these 4 or 5 questions. And someone I work with, she did that, and then she created infographics about it and basically said, on these kind of days with this kind of weather, you get the most traffic here and here. These are the stations you should invest in. These are the stations you might consider dropping because you're not making any money there, and nobody rents your bikes there, right? So she could do things like tell those answers, but also what is the social graph of where people travel in the city based on those bikes. So sometimes you can still take this pretty far with smaller data, and that was maybe 250,000 observations or so. Yeah, I guess that's not that small. Sorry. It looks like you're ready, Chris.
Yeah. Actually, maybe I can grab the microphone.
You want this one?
Thanks, too. Maybe the microphone. Asked David to come and speak about all this because when the last course that we taught, data scientist training for librarians, this is the second iteration of it. All the students said, "You explained it so much better than I did." And so I listened to them, and I convince you to come back and explain it better than I can. But I guess my job is to explain how this might relate to, and I'm having a hard time with this thing, with how it relates to librarians, to libraries. And I think the way that you ended with like challenging the way that you do things traditionally, I thought that was a great way to end, because that's what we're trying to do. I think in the course, it's just the whole idea of the course is to challenge the way that we've been working as librarians for a while. And one of the things that you you probably don't live in this world, but we do. Some of the librarians, but just to give you an example or an idea behind the picture and everything like that, the painting, is that one thing that was really, when the National Science Foundation came out and started a data management plan, they were listened to the community. Everyone was saying, you should share your research data to all the researchers out there, right? They wanted to encourage this. And the National Science Foundation started this data management plan, hoping that it would inspire people to start sharing their research and other things that are federally funded, right? When that first came out, a lot of libraries were like, "Oh, this should be an area that we should be in," and they started grasping at straws and like, how do we, how do we help our researchers with this, because we feel like we're in this space. We should be helping our researchers with it. And the joke was, I got this from, they told me that it was a combo of them, Patricia Sue and Dorothea Salo, who are pretty big in this area. They were joking that when this came out, that it launched 1,000 sites. All these libraries around the country started putting up websites to help their researchers with, this new mandate that was coming through. The NIH had done it before them, but it really started this whole trend, right, in libraries. And so we started trying to develop all these different types of services for our researchers. And some universities, their libraries hired one data librarian to help the whole university, and that all the weight of the university's research data needs was on that data librarian's shoulder, they tried to put up as much as they could on the websites, about how can they help researchers with these various things, like here are all these repositories, go there, deposit your data, and so I got caught up in this. I lived outside of this world until I got to Harvard, but I remember I went to a conference where a librarian was going crazy about, be careful of this, e-science is coming, research data, you have to worry about research data. And I noted it and I said, yeah, if I ever go to academia, that sounds like something I should know. And when I got here, Harvard wasn't doing anything about it, really. Maybe pockets of it. The libraries have gotten into it now with the Research Data Collaborative that Gosha Sturgis has started. But a lot of times when I go to these meetings, I still see that. Try looking up big data on the web, and you'll get. There's a shirt with Data's face on it. It says, "I like it when people call me Big Data, like Big Poppy." But one thing that I noticed is that when we were trying to scramble and create all these services, that all the people involved had not experienced working with data. I could tell, because I had worked with data. And I could tell, and I worked at CNET doing data mining and all these different things, and I could tell that if I was a researcher and I went to a librarian and I said, I need help, most of the time when I say I need help, it's with all that other stuff that you were mentioning, like all the work that goes into, do you have advice about tools that can help me improve my workflows? Do you have advice about this? The other stuff, the data management plans and all this, it's becoming, a part of these NSF proposal processes and other things like that. The administrative side of a university will handle that, really in the end, is that a space that librarians should be in? And I always wonder about that. And but I still think it's important that we know about that. But I think the importance is working with the data, experiencing this life cycle so that we can actually assist our researchers. So that was my first aha when I saw all these librarians scrambling and saying, what do we do with, I kept thinking, they need to experience the data life cycle. They need to get a better understanding of the researcher's data needs. But it helps them sympathize with where the researchers are going. The researcher doesn't come up to them and hear, I have a need, and then you just say, go there for your need. They're not going to come back to you. And so we're actually kind of pushing them away, I think, instead of drawing them in. And some of the other libraries are not worrying about this so much at the moment, but you should, because data is going to become even more and more important to every aspect of, Dave just talked about it, so I don't have to. The other side is that doing this, learning how to work with data, I noticed that in how libraries are trying to restructure these days, and that a lot of, well, I'll just say it, in my experience at Harvard, in the Harvard libraries, a lot of projects have been guided by the traditional water flow project model, project management. It's all about the process. It's not about exploration and growth. And so in the end, we're trying to reach these deliverables without someone actually, the people involved with them growing. And so another project that was here at Harvard called the Harvard Library Lab, we had all these innovative ideas. We brainstormed, we threw out all these, we made proposals about ideas, but we farmed all that out to places like Berkman, or to other, Berkman Center, or other places to do the development. And so we just sent them our ideas, and then we didn't contribute in the process. We didn't grow, we didn't grow as librarians. And so, another thing I saw was that there, in all these processes and other things like that, it's a lot of talk, it's a lot of reports, but no action. And it reminded me a lot about when I first started programming, and when, people in this course, the data scientist training course, and every other time I've seen people trying to start out programming, it's the hardest thing to try to start writing code, and that's the part where you start experiencing failure and being comfortable with it, because you're going to start writing things and it's going to start breaking, even at line 2, line 3. But that's the part you're trying something new, and you're failing, and you're learning, and you're growing. And as you're doing that, you are able, to grow as someone, to contribute, I think, to the change that I think we want in libraries. So I think that the future of libraries can be found in this kind of environment, that hackers are in, the mentality, it's, the lack of fear of failure, the ability to ask questions. I was in a meeting ran by a project manager here once, where someone said, I have an idea about this project, and the project manager said, well, let's table that for the time being. And I wanted to run out of that room, because in any case, whenever someone says table something, that idea could change the way that you're thinking about some things, and you should really listen to that and iterate upon it. And so the other thing I noticed too is that, and maybe some people don't agree with me, but I do think that librarians should learn programming. I think that one of the other projects we had here at Harvard is about interoperability. And again, we started farming. We said, well, we're going to leave all this stuff to the programmers to figure it out for us. We are the ones that can help with interoperability. If we learn how to program, we can be the conduits. We understand our domains. We talking to each other in this environment can do amazing things that the programmers, in fact, once they hear us talking, can in our past data science for trainings course, we had one guy from the programming community come in, and he ran out of the door like excited about all these different things that we're doing. We connected him to all these different things, and so because we started understanding the underlying technology, so it's an amazing experience. And a lot of this comes from my own experience of having access to the data, being able to work outside of library systems, because that's another thing that shackles us. We're in a cycle which we cannot break out, where we keep buying things from Ex Libris or from all these vendors, and I don't want to single out one, but we buy packages, and we don't really understand that once you learn these technologies, you can break free of them, and you can do some amazing things and move beyond them. And there's an open source community. And so that's what I did with data from the NASA ADS, which is an open system. It's our literature database in astronomy. But they're lacking in some of the things that librarians traditionally do, is make these connections, these data points, right? And so I did a lot of bibliometrics for the European Southern Observatory, and a lot of the data that we pulled out of the NASA ADS, we thought about the data constantly, and we did new things with it. And when I left the European Southern Observatory, they said, we had a review at the same time, and all these head scientists from all over the world came up to me and my colleague and said, we hear the library is the best thing at this institution. They were half joking, but they weren't, because in every meeting they used our metrics. And they said, that is so helpful to see all of that. It really frames things for us. And the other side is our little experiment that we did here just recently. Louise, who's right over here, Louise Rubin, we took some more data in the ADS, and we mined all the grants data. And by that point, we hadn't gotten our visualization components up in the library yet, but we said, let's just release the data and see who's interested in it. And a guy from University of Washington grabbed it. He's an astrophysicist, and he started doing all these amazing visualizations with it, and it went into the Atlantic Wire, where it was pretty influential. Like, a lot of people followed it. I had astrophysicists come down into the library, which had never really come down in the library, and say, you guys are doing great work in here in the library now. Like, that was helpful, understanding, like all that. And I said, we didn't do all of it. It was the astrophysicists out in University of Washington, but it really had an impact. So, and Dave stole some of my thunder here, but yeah, there is a huge need for this. He cited this study, and 1.5 million data savvy individuals that we need. I think it's going to be more, to be honest.
I've met with the authors of this study. They think it'll be much more.
Yeah, I think that librarians are actually kind of positioned well if we decide to move into this area. So yeah, that's the other ha-ha moment, is that librarians can play a vital role in the big data space. And just like Dave said, the whole process of putting your keys and, like the whole process you go through every day, breaking free of that and trying this something new. And it'll be extremely valuable to your library system, I think, to try this. And so you're all here to learn about the data scientist training for librarians course. Yeah, I mean, this is something I first said in our first course, is that you're going to be frustrated, you're going to hate me, but you're going to start loving it. Like, you're going to start. I think it fuels something inside of you, like where I heard people starting come up with all these ideas. Like, once they started to break free of the traditional library systems and started thinking, I can do this, I can do that. That's an interesting idea, and starting to explore it. And so, like, all I can say is the course itself is a frustrating experience. You're gonna fail. And that's all right. That's all right. That's part of the whole experience. That's about changing our mentalities and how we work. And if anything, that's the biggest takeaway, I think, like, is how you come away as a different person, how you view things. And I don't, Luis, do you think everyone came away with different outlook on, I think they did. I think everyone was excited, and they started their own group after this and wanted to share with each other and try all these things. And so well, it's off the screen. But the course really follows this life cycle. The data sources, extraction, cleaning, the sharing, the presentation, the visualization of data, the storytelling. So we follow the whole track, and it's this secular, you constantly revisit this. You go back to the data sources. You keep going around in a cycle in this process, and you can even revisit parts of it too. Like I think Dave had. I wanted to draw even more arrows in his, because you can go back after point 2 in his cycle or point 3 and revisit if you see something that doesn't seem right or that you want to challenge. And the other thing about the course is that it's starting soon. Starts August 23rd. And I guess you can say right now that we're going to start with boot camp, a software carpentry boot camp. And some of the people that you saw David talking about are going to teach that course. And it's usually geared towards scientists, but it's good for us too, to learn this. They start off with Unix, Shell, and Git, and Python. But we're going to move on past that, and still solidifying some of the speakers at the moment. But Tom Morris is one of them. He's here, and you are going to teach Open Refine and Python. We were talking about how he's going to focus on essentially working with data sources and then partially wrangling with that data, of course, in Open Refine, but also Python. And then we'll move on to some other courses, more in Python, and then R, which is the other language that Dave was talking about, which is more geared towards visualization. But you can also do the same things, data wrangling and that as well. And then to try out some other things, like have guest speakers come in, which the students really loved last time, actually have people come in and speak about what they're doing. And that was part of it is already right now with Dave, talking about the data science course that he's teaching, and about the life cycle as well. And in the last course we had a representative from the Sunlight Foundation come and speak to us about government data. And then we had a data journalist come from the Boston Globe and speak to us. And so this time we're going to try and do that as well. But even our instructors are people from out in the field, and they bring in their experience, which is also very interesting. I think it helps with the course. And at the moment, we're thinking about 2 classes a week. That could still change because the instructors are, after all, we have to work with them and their schedules, and because it's difficult to get them. One of the more difficult parts is when I first come and say, I think librarians should learn data science, and they say, librarians? Really? And they get caught off guard. You got caught off guard. It was like, librarians, why? And then when I start talking to them, they say, aha, we see some of the connections here. We see that, and that this is a group that that should be doing something in this space. And so then they get really interested in the course. And so in the end, we don't have a problem getting instructors coming in, but it takes a while to convince them. But in the end, they're sold, I think. And the other thing is we talked about homework, and we're going to try and do homework. So lightweight homework in this class. We didn't do it last time. I'm going to try and, because I see it's going off the screen here. Let's see if I can try and go to something. Well, but most of it's there. And the other thing is that we're going to try and do some projects in the course too and present them at the end, just like we did it last time. And it's going to be similar, but we've learned from the last course. And I really recommend that you go and you speak to, you speak, or not speak, but listen to the videos, see the videos online. Nothing's working. There we go. Well, so here's the sign-up link for the course. This time around, we're going to take about 40 students, we hope. That could change. Depends on how many people apply, and it's free. That's freeze and beer. It's free. I mean, it's great. I wish that I had something like this when I was starting out. I had to teach myself. Programmers were nastier when I started out. Now everyone is very much friendlier. Like if you go on Stack Overflow, which a lot of the students used in the last course, and it's one of the most useful resources for learning, then people are much more friendly. When I used to go on these forums, people were nasty, and it was hard to learn. But I wish I had something like this when I started, that was like a collegial group, people that were enthusiastic about teaching you, and it was free, and buy a library. It's just, I highly encourage you to register. We're looking for students that stand out, so I think we're trying to look for diversity, we're trying to look for librarians from other universities, because Harvard has a tendency to be insular, right? And part of this course is, again, to have a group that's diverse and that, we can learn from each other. And then just passionate, dedicated people. We're going to try and filter the people out that say, I want to take the course. Well, there has to be a reason why you want to take the course. You can't just say, I want to take the course. You have to tell us why you think this is going to, change your work, your life, whatever. It's something that stands out, again, that we are looking for, because initially when I first started the course, there were a lot of people saying, I would like to take the course. And then, some of them dropped out, or, you could tell in the emails they started asking a lot of questions, and their hearts weren't really into it. And you do have to be dedicated in this, or else it's just like 4 legs on a table, one leg leaves, and then the whole thing falls apart. You're in groups, you're in projects with these people, you're learning with the people in the group. And if you leave, that's a big part, I think. Like if people leave, that diversity is affected. And so, sorry. Did everyone record? I guess I can send this out now. I wanted to lure people into coming here, because the webinar, that's another thing, is that everyone asks, is this course online? And it goes back to Coursera, and all these other people are going to come in and come out, and they're not going to stay for the whole course. And you have to come here. Well, it's not necessarily going to be here. It's going to be different parts of Harvard, but you have to come and you have to participate. You have to be invested. This is our badge for the course. You get one when you finish, or we actually got one halfway through. But it's done by a local artist, comic book artist, David. I'm blanking. His name is on the Dirk Tiede is his name. And here's my Twitter handle. We were talking about the importance of Twitter, but just to show you, I have my image references here. I'm a good librarian. So if you have any questions at the moment, you can ask. If you still have questions for David too, we're here to answer them. Probably a lot of questions about the course. I didn't answer all, I'll probably say everything, but let me know if you have any questions right now. Yeah.
Will you conduct the course during working hours?
It's probably going to be a mixture. It's probably going to be sometimes in working hours and sometimes in the later evenings. So the schedule hasn't been finalized yet. We're probably within the next 2 weeks it'll be finalized. I do know that the 23rd and the 24th of August is when we're having the boot camp. So one full day on Friday will be, and you'll have to come in on a Saturday. So, and that's sort of that speaks to the students from the last course. One of their points of feedback was, you skipped over command line. And I said, I know, I wanted you to start programming right away. And they said, that's important. And I said, I agree. You know, I kind of assumed that you could get past that point, and we did have some hiccups along the way. But I really wanted them to experience the programming side of it. So we're going to cover a lot of the basics. That's going to be a boot camp style, 2 days, 2 full days. But for the most part, we're going to do 2 hours a day, and hopefully towards the latter half of the day. And yeah.
Can you talk about some of the projects that the last class did, or that you anticipate the next class will be doing?
Well, this time I'm not designing the projects. That it's being designed by librarians from the other course. But the last course we did, and it's still possible in this course, is that a lot of our projects involved connecting to other resources. So like one group did visualizing, looking at the data, the linkages between a HathiTrust or Internet Archive and the NASA ADS, and looking at what are the differences between what do they have, what does the ADS have, and then visualizing those differences and the connections. And then another person did. Let's see, I'm blanking. But there's another group that did grants. They did a connection with grants, and that was Louise's group. A lot of that stuff is up on the website. I wanted that all to be open, and so you can go to the website and look at their projects, their data stories, as we're calling them on the website. And some of them are available. The presentations are online too from the students in our blog, I think, or on the data stories part of the website. So, yeah, there are students from that course that were at like different levels. Like there's one now, she's doing NLP, she's doing NLTK, and using that to basically mine through the literature and do natural language processing. And it's amazing. That 3 months, I always tell her, I say to her, it took me years to figure out what you learned, and she's already doing it. And so I've been amazed by some of what people have done in that course. I know that in my own group, Louise has become like a Tableau master. So she knows Tableau well now, and so I'll just ask her to do something, and it's great. Like we have. But it really varied, Some of the students talked about how much they failed in the course, which is great. I encouraged that, right? And then others really had something to show, and it just really ranged, and everything was okay, as long as they went through the experience and then they presented about their experience. So, and that was the whole point, is to change the mindset. Yeah.
Committed some weeks away from Cambridge, so that means I certainly miss classes. Would you consider to have a streaming video just to give that?
No.
Okay. No.
No, and it's not just because there's another reason for it. We did try it. We did try it for the people that really did come for like 3/4 of the course. Like they really wanted to take it. You could see the desire, And so you wanted to let those people in because you knew they really wanted to be a part of it. And we wanted to help them be in the course. So we did try to do WebEx and Google Hangout and all this Skype, and it just wasn't working. The experience is not online. And we did have some people miss some courses. Like, I don't know, the average was like 2 or 3 of them. But, yeah, that's important to come, to be in, because you'll understand. When you do it, you'll understand why it's important. So, yeah.
Do you have to have previous programming?
Yeah, that's a question. I'm glad you asked that question.
What level of technology skills should someone have?
What level of technology skills should you have? What I'm thinking when you take this course is I think all librarians have a basic understanding of HTML. Like they've had some experience of it in their work, and with SQL in some way, like databases in some way. That's what they learn in library school traditionally. But really, it's fine if you start at the beginning. Everyone in the last course really started at the beginning. And so actually I prefer that, because I think that the people that are starting at the beginning really need the help, really need the help to catch up and do these things. So I think it's even a more rewarding experience because they're more invested in it. They really want to take the course. So, yeah. So yeah, you don't need to know don't be intimidated. Yeah. But if you do know a little bit, then it doesn't hurt as well. Who's planning on taking the course here? Okay, it's most people. All right, great. All right, I one of the amazing things is that that we have people. I have librarians in New Zealand, in Germany. In fact, in one of these big library organizations, they just had a meeting about next steps, and they listed this course as one of them. And JISC in the UK does. You always think they're doing amazing things. I went over there and they said, yeah, well, we do a good job presenting our projects, but one of the things is they realized what I realized in our data services. They realized that they needed to do this other, they because it wasn't entirely working, and they needed people that understood how to work with data. So around the world, there are people wanting to do this. I talked to librarians in Colorado that are thinking about starting their own group. I've talked to librarians everywhere. It is amazing. And I try to respond to all of them. And so again, I can't stress to you how lucky you are to have this opportunity if you're in the area and you can register for it, because I think it's rewarding. So, anyways, yeah.
So it's coming up in 4 weeks. I've already scheduled a certain vacation in the fall. Is it okay to expect to miss a class or 2?
Yeah, again, we had people that missed like 2 classes in a row. Or just don't miss more than 4. Then you're going to be completely lost. And I think we're going to have to figure out how. We never did it in the first course because it was so experimental, but how do we have people keep up if they don't make it? But yeah, so of course, you have things going on in your life, like you're going to go on a vacation for a week or something like that. Then people did that and they left, and then they came back and, I missed so much. So we're going to have to figure out how we, the way we did it in the last course is that I had a student TA that took notes, and she collected everything and she posted it on the site. So you can actually look through the site already and see our notes from each session and her blog story on it. She did an amazing job, Jennifer Prentice, and she told a story from each class, and so people could follow that if they wanted to. That didn't show up, and so that's one way we'll try and do it. Yeah.
Are the courses held here in this area of campus?
The first two will be here in this room. And then later on, it'll be at other places like the Lamont Forum in the Harvard Libraries. There may be some other venues. We'll see. So, yeah, Mark, sorry. There were a lot of questions.
Are you thinking, if you can't make the time commitment this fall, are you thinking of future courses?
Well, Scott can answer that question. I think I will die. You know, like I'm so you were talking about your wife earlier, and I talk to my wife here too, and she says, "I thought you weren't going to do this again." And I said, "Yeah, but it's important. I need to do it, and I need to be involved in it, and I hope that it continues. I think I myself will have to be involved more with a group that does it, you know, and this time around there are more. I should say that there are a group of people involved in this project. I said students from the last course, Christine Eslau, Colin Van Alsten, and then, you know, Scott Wicks is, of course, you know, he's here and he's supporting this along with Michelle DeRocher. And, you know, the next time around we may have more people to help with planning this. And I know that Scott, I think, wants to do this again. So, yeah. So, yes.
I want to repeat Gosha's question about scheduling. There are lots of us who can only dedicate our time during working hours. There's no way I can tell my husband I'm going to do something that takes me away from my kids, and sorry, you have to take care of them.
Yeah.
So, if there's any chance that you can reconsider the schedule for this fall to be during working hours, I would raise my hand right away. If you consider if there's a chance to give this course again, please do consider restricting it to working hours. You're limiting a lot of potential talent by not.
I know, but you know, the other side of it is how do you bring in these people, these amazing people, to teach this stuff to us? You know, like they have schedules as well. You know, like and so you have to be flexible to them because they're doing this for free. Well, sort of. They were in our course now. You know, we changed a bit, but they still are making time within their schedules to do this for us, which is still at a huge discount than where you would go. You know, if you had to go out and get this training in other places, it's a huge discount. You know, like, and then, you know, I can say that is our goal, to try and get it during the work week. We know that we're trying to do that, but that having said, you know, the other part of it is that's the huge obstacle we have to work with. You know, is trying to get it so that it works for the instructors as well. So. Yeah, I don't know what to tell you, but we'll try our best. You know, that's the thing. We'll try our best. I guess one group that this is very good for is Simmons students. You know, like that's we had some Simmons students in our last course, and it was great having them there because they do have a little bit more time to play around with this stuff in their studies, and I mean sometimes they have huge course loads as well, but. So the Simmons students were able to add value to the course. So, yeah, there was another question.
Well, it's not so much. Oh, okay.
Yeah, sorry.
Simmons student. I'm a Simmons student at Library Science. I know you already killed the idea of doing this online, but I just want to voice out a need for as a student. You know, I just stay here for a year or two, and now I know this amazing course and. I'm doing internship at the BC right now in the e-science internship, so I really get into this field. I love it. You know, I want to know this could be my future career, and I don't know where I'm going to end up after graduate. And I know this course is going to be, I think, is going to be a amazing resources for my future career development. I just feel like, you know, if you could make it online for users like me, or even think about redesign the course, make it like a short course for bring other people coming to Boston, just stay for a couple of weeks.
I should add that there is a slight possibility that there is a course being taught at Simmons as well on you know, some of the, I call it like the 30,000 foot level of all this, you know, much more on the level of you know, like, and Andrew is involved with that. He's up in the front. It's being taught by UMass, and it's about you know, research data in general, the life cycle, you know, about policies that I've pointed to, briefly talked about, but their course really expands on it. And then there's been discussion about this half, about really working with research data and getting your hands dirty and experiencing the other side of it. And so there's been talk about Simmons incorporating something like this as well. So I really do hope that proceeds, you know, like that we start doing this more in Simmons. But for the moment, all I can say is it won't be online, sorry to say. Our presentations at the end can be online. We may want to do online for one of our guest speakers, but I should probably put on the lights here. I think this will help. Oh, Simmons?
No, she said something about Boston College also.
Oh, yeah, what did you say about Boston College, actually?
Are you there as well or no?
Shell, yeah. Shell, she used to work for me, by the way.
Yeah, Boston College, they have amazing e-science group. Sally is here from Boston College. It's a group of science librarians. So they have a e-science internship offered for Simmons Gisley students. And I'm their number 5th internship this summer. Yeah. So we've done a lot of amazing things, great projects. Yeah.
Great, yeah. Oh, it's great you have that opportunity. Yeah. Any more questions? All right. Let's go. Thank you. Thank you, everyone.